This is Britt Caswell with another example video. In today's video, I'm covering example 2 from section 5-4 in the SavvasRealize Algebra 2 textbook. The goal of today's video is to learn how to rewrite a formula as well as to solve with it. So let's go ahead and take a look. So this problem is actually dealing with the Golden Gate Bridge. Good lord. So it says that the suspension cables from the Golden Gate Bridge's towers are farther above the roadway near the towers and closer to the roadway near the middle of the bridge. You could see them right here. That's the suspension cable they're discussing. It says you could figure out your distance from the middle of the bridge, x, in feet, and the height of the suspension cable, y, in feet, by using this equation. And they want to know how far the cable is from the roadway when you are about 200 feet from the middle of the bridge. So let's go ahead and let's take a look at this problem. So this 200 that they're giving us, by the way, that's an x, right? Because that is our distance. So in order to solve this problem, we need to isolate y, or get y alone. So all I'm doing over here is I am rewriting the formula so that I can manipulate it a little bit. All right, now the first thing that we need to do is we need to isolate the square root. So this hideous decimal that's chilling here in the bottom, I'm going to multiply both sides of my equation by it. And so while I'm kind of writing this out, usually we want to solve the equation for the variable that we're looking for, because if I just start doing calculations on this right away, I'm dealing with this really ugly, really ugly decimal, which is going to make more really ugly decimals, and it's going to create an approximation because you can't type all those numbers into your calculator. So by just leaving it be for now, that's allowing me to get a more exact answer. Alright, so now my radical's alone, so in order to remove the radical, I'm raising both sides of the equation to the second power. Alright, so this really doesn't look any different. Now you could square that stuff, but I wouldn't worry about it yet. Oops, not 200, 220. Watch those number details, right? And then our last thing here is to remove that subtraction by adding. And so I'm going to add 220 to each side of the equation. Alright, so my equation now looks like 0.010583x squared plus 220 equals y. Ooh, and I have the number 200 in my brain. Look at that. 220. Alright, so now we're using the fact that they're giving us that number 200, and we're going to plug that into our formula here. Alright, so where the x is, I am now replacing it with the number 200, and I'm multiplying that in there. Alright, now for the sake of being able to show it to you guys, because I'm just going to use Desmos so you could see it. I just took a picture of it with my cell phone so I don't forget my numbers, and now we're going to calculate it on Desmos. Now understand, we're doing multiple operations in this, so you need to make sure that your grouping symbols are appropriate for what you need done, okay? What I would recommend doing is practicing with whatever calculator that you're doing your arithmetic on, because different calculators have different requirements for plugging things in. So now I'm just double checking to make sure that I typed everything in correctly. It looks good to me. So the question itself doesn't tell us how many decimals to use, so I'm just going to round to the nearest foot. So I'm going to say I'm about 225 feet, or the cable is 225 feet from the roadway. And remember, with word questions, you generally want some kind of word solution. There we go. So there is my word answer. So let's go ahead and let's try one more. So this one is talking about the speed of a vehicle. All right, so we have some kind of car. Here's my junky car. Zoom. All right, so the speed of the vehicle in relation to its stopping distance. All right, so understand the stopping distance is how far the car continues to move after you hit the brake. Okay, and they give us this formula. It says, what is the equation for the stopping distance in terms of the vehicle's speed? So what they're asking for is d equals what? All right, so I'm just rewriting the equation. And so to solve for d, our first thing that we need to do is we need to isolate this radical. We've got to get it alone. So I'm going to take that 3.57 and divide it on both sides of the equation. Oops. Struggling with writing this video, I swear. Alright, so when I do that, I get v divided by 3.57 is equal to the square root of d. I'm going to get rid of this d down here before I confuse myself. Now remember, to get rid of a square root, you just have to square both sides of the equation. Alright, so here I get v squared, and then I need to do 3.57 squared, which is 12.7449. That's hideous. But there it is. That is our equation for stopping distance in terms of speed. Alright, this is the type of formula that you would see used like at like a crime scene. So they might measure the skid marks to see that stopping distance to determine the speed of the car. I mean, there's more to it that would happen, such as like if the road is damp or the tread on the tires. But this is the basic idea of where that formula comes from. So there we have it. That is how to rewrite a formula. Until next time.